Welcome to Math in the PM, second try. Anyways, I wasn't reading carefully, so I'm just starting this over again here. We're looking at scale diagrams, mostly reductions, but we will look at some enlargements as well, just like 7.1. Okay, we're reviewing some skills. I'm going to show it this way, and I'm not going to even try the other way. Scale factor answer. Okay. Scale diagram, the answer to the scale diagram is 36. So here's the thing. Something times 0.25 equals 36 centimeters. So you'd have to figure that out. You could use it by division. But I'm going to show you a way with fractions that I'm going to use to set up always do this. Okay? Thank you for getting that. Here's what we do. If your scale factor is a fraction, you put it on one side. If it's a decimal, put it on the other side. I can just stop for a second. So, as it was saying, if it's a fraction, you put that on one side. But when it's a decimal, I'm going to get you guys to do this so that we use the same method every time. We're going to say one fraction equals another fraction. Now, a quarter, you might know that as a fraction, 1 out of 4, but I'm going to pretend I don't know. I'm going to put 0.25, and to make anything a fraction, if it doesn't have a bottom number, what is the one number you can divide by and not change anything? I see it, I see it. Two people have already indicated 1. 0.25 out of 1 is the same as 0.25, but I'm doing this so we can use the same rule as before. Now, I'm going to remind us the original or actual is always on the bottom, and then the scale model or diagram, scale number is on the top. Okay? Scale factor. If we had the fraction 1 out of 4, we would have had the 4 at the bottom as the original and so on. Okay. I just put that in green because it's not really part of the math. You got to just know that. Okay? We call that the letter K. Remember, K equals decimal 25, you come up with that. Okay. The scale diagram of the motorcycle is 36. So the scale number is always on the top, on the left, and on the right. So I'm going to put the 36 here. And the scale factor is decimal 25. Determine the actual size of the motorcycle. I'm going to just use the letter X because it's a common algebra variable. I make my X like handwritten. There we go. How do I solve one of those equations? I said it over and over again before. Cross multiply the diagonals, cross the equal sign, divide by the lower. In this case, that's 36 times 1, divide by 0.25. You have to really multiply by 1? No, but just keep in mind that cross multiply. 36 times 1, divide by the decimal 25. It's really times 4. 144. So I'm going to write down underneath here, X equals 144. Now I know 36 was in centimeters, so I'm going to say centimeters as well. That's my final answer. Clearly identify that's my final answer. Tell you what, guys, too. I don't like showing mistakes, but I'm going to say, don't do this. Okay, it's going to disappear because it's wrong. Because really, 36 or decimal 25 over 1 is not equal to 1. It's just an incorrect math. Work down. You guys are big kids now. Work down in algebra generally. It can work. Okay, let's try this one. The snowboard has a length of 230 centimeters. The scale factor is 1 out of 4. This time it's given as a fraction. So the scale. 1 is the scale number, 4 is the original number. 4 to 1 ratio, 1 to 4 ratio, whatever you want. What is the length of the snowboard in the scale? So the scale diagram is what we're looking for. That's the X. The actual snowboard, the original measurement is 230. I'm able to do this. Now, I use the same phrase that pays, cross multiply, divide by the lower. In this case, the cross diagonal numbers, 1 times 230. The lower is always diagonally across from the variable. divide by 4. So it's really 230 times 1, divide by 4. I got 50 seconds. There we go with this one. Okay. Okay. You guys seeing this? We've done this kind of stuff before. Got to practice it up. 3. The top view of a rectangular patio table has length 165, width 105, center. A reduction is to be drawn. With a scale factor of 1 out of 5, 1/5. Find the dimensions of the reduction. So this is basically, you've got to do both measurements as 2 separate problems. So I'm first going to do the length. I'm going to say, well, 1 out of 5, 5 being the action. We want the scale, the reduction. So I'm going to go with the 165. I'm going to go 165 times the number 1, because they're diagonally across from each other. Divide by the lower, divide by 5. So 165 times 1, divide by 5. 33. 33 centimeters. Now the width, same method, but different numbers. So I'm going to say 1 out of 5 is equal to x out of 165. Type it into the calculator. Oh, I said 165 again. That's 105 minus 105. Yeah, 1 times 105 divided by 5. 105 divided by 21. Okay? What I'm really looking for, as much as the answer, is that you're setting up the equation as a proportion. So just as much as the answer, I want to see this 1 out of 5 equals x out of 1 of 5. Okay? That's really important. So don't just write down 21. Here's the dimensions of the reduction. And they're labeled under the columns. Okay. Last one. The water ski has a long length, 1/7. That's the actual. The scale factor is decimal, 0.4. We're going to use the decimal trick out of 1 to make it a fraction. What is the length of the reduction? 0.04 out of 1 for the actual. Scale is 0. So the scale is the reduction, x. The actual item is 1/7. I'm going to say, well, x. I know how to solve this. Cross multiply the diagonals. Decimal 0.4 times 170. Divide by 1. If you want to put that in, you can. 6.8 centimeters. Cross multiply, divide by the lower. As long as there's no addition or subtraction in those setups, you can just do that without understanding the algebra. You can just say cross multiply, divide by the lower. When you get more complicated expressions, you do have to do algebra. But we don't have them in this section with me. Okay. Any questions from the first page? Okay, that's just a review. We'll get some stuff going on here. Yeah. And okay, and the example here. Really, enlargements and reductions aren't really that much different from each other. It's just you're making things small, but the math part's similar. The cylinder is to be enlarged, so that's why I threw enlargements in with reductions. Cylinder is to be enlarged by a scale factor of 5 out of 2, 5 halves. Find the dimensions of the enlargement. Now, first, before that, you guys understand 5 halves is bigger than 1? That's why it's larger, and it's 2.5. So I'm going to use 5 halves as a fraction. It actually makes it easier to do our math. I'm going to say, well, 5 out of 2 is equal to, and then, well, I guess I got to use the diameter first. I'm going to label this diameter. Then we'll do the height after. So the actual diameter is 2 centimeters. This one I don't even have to type in because they're equivalent fractions. You see what I mean? 5 out of 2 is equal to what out of 2? 5 out of 2. That's the dimension. If you want to put it in your calculator, it's going to be 5. You say, well, 2 times 5, 5 times 2. Divide by the lower, divide by 2. And it's going to come out to be 5. Like, that's just a coincidence. Now, the height, 5 centimeters. It's not as easy. You can't just look at it necessarily. And look at this. Height, 5 times 5 divided by 2. The calculator, you get 12 and a half. So when it's enlarged, you've got a diameter of 5 and a height of 12 and a half centimeters. Yeah. So do you see how the math technique is the same every time with the fractions? That's why I'm even putting the decimals as these fractions. Then you don't have to think about whether you multiply or divide. You can do it another way. Enlargements of a photo are to be placed in different catalogs. The original photo has a side length of 4. Now, I'm telling you the scale factor, it's larger. Factor of 2.5. And if you consistently, and I know someone who probably would consistently not do it with our fraction setup, go ahead. But I'm suggesting most of us set it up like this. If you're given a decimal, make it a fraction. Actual is always on the bottom. The original or actual photo is 4 centimeters. That goes on the bottom, always. And now I just say cross multiply. 4 times 2.5. I don't have to divide by 1. Centimeters. The side length for an enlargement is 10 centimeters. Math is just, it doesn't get any tougher, really. Scale diagram of a rectangle has a length of 15. That's the scale, not the original. The scale factor is 1.2. What's the original? Okay. So 1.2 out of the number 1. The original is the bottom. So 1 is matched to X. 1.2 is matched to 15. X equals 15 times 1 divided by 1.2. 12 and a half. Right? Hey, guess what? Two octagonal, octagon, 8 sides, octagonal garden plots are similar. Now, when you hear octagon, don't you think of a stop sign normally? You don't? And stop signs there, right? I want to just mention something. But that is a regular octagon. It's one where all the angles are equal. Octagons, is your sheet cut off again? Gosh darn it. Yeah, that's a good comment. Okay, I'm going to find the textbook page. That darn photocopy, when I send things to the photocopy. What's that? I can't hear you. Okay. Good. I'm gonna look it up. You guys are gonna look it up. Textbooks. Like I have it here. I know what it is. Which page did I get it from? Oh, did I take that from a different book? Okay. Don't worry about, or is this? Okay, you'll just do it by looking with me, okay? Can you guys read this? My first thing about an octagon. Octagons, when you think of a stop sign, that's a regular octagon, meaning all the angles are equal. Equilateral, in other words. Equal angles, equal sides. This is still an octagon, but it's all the different sides, different angles. It's got kind of a concave an even side. So don't be fooled to just think that like a hexagon, it has to be a perfect six-sided, equal-sided shape. It could be a different side. Okay. We'll just do this one because I did get it from a different book. So here's what we're going to do. Calculate the length of GH. So I find GH. I'm darkening that in here because you guys are doing strictly by video. That is just like QP, isn't it? Well, here's what I had to figure out. You notice that AB and IJ are similar too in the shape, like their corresponding sides. So what we're going to do is for A, is we're going to set up the ratio with the green measurements, 5.4 compared to 8.1. And they're both in meters, so this is good. So I'm comparing these two. If 5.4 grows to 8.1, that's going to be in the same ratio as from the little guy. We don't know this. It's what we want to find. I'll call it X instead of GH, which is matched with the big shape, 32.4. And this only works because I have information about the little shape on the top. Little shape on the top, little shape on the top. And then I made sure that the bigger shape is on the bottom both times, right? Big shape, big shape. You guys follow that? That has to be set up that way. You have to flip around. Okay. How do you solve this? This time you definitely need the calculator. Cross multiply, divide by the loader. 5.4 times 32.4 divide by 8.1. So we did this one together and I realized I don't have the time. 21.6 hours. It didn't do. Then we're going to look at NP. NP is on the big guy. That's the same corresponding side as this 27 over here. But guess what? We started out the same way. The reference for my scale is in green. I say 5.4 from the little guy. It's just matched to 8.1 corresponding on the big guy. That's going to be equal to the ratio of the little guy's side is 27, which is matched to NP, so I'll call that the X. And cross multiply, divide by the lower, 27 times 8.1. Divide by the lower, 5.4. It's cross 40.5. There's my answer. My
you're gonna hand out something. You're gonna practice these questions on
This sheet that I'm handing